Very good morning, children. Welcome you people in class 11. Physics is a very interesting as well as challenging subject. We are going to start chapter 1, that is physical world. In this chapter, we have to know about what is physics, its scope and excitement of physics. Physics, technology and society, fundamental forces in nature and nature of physical law. Here I would like to quote Albert Einstein. Science is not just a collection of laws, a catalogue of unrelated facts. It is a creation of human mind with its freely invented ideas and concepts. The reality created by modern physics is indeed far removed from the reality of the early days. Means why we study physics? What we can achieve after studying physics? These are, and how physics can help the society, the mankind. All these we have to learn step by step in the whole year during our class transaction. See, nature is pleased with simplicity. In our country, it is also quoted simple living and high thinking. Because simplicity is directly related with nature. See, what is physics? The branch of science which deals with correct and precise description of the material universe is known as physics. In this physical world, anything is happening. Why that is happening, how that is happening, what idea we can draw from them, these are the core concern with physics. Physics is classified into two, classical physics and modern physics. Prior to 1890, the physics known as classical physics, Newton's laws of motion, gravitation, laws of thermodynamics, kinetic theory of matter, Maxwell theory of electromagnetic radiation, and some important areas of classical physics. Modern physics after 1895, or we can say after 1890. Key Rontgen discovered X-ray, Henry Becquerel discovered radioactivity, discovery of electron by J.J. Thomson in 1897, quantum theory by Max Planck, special theory of relativity by Albert Einstein are some important discoveries, given a new shape of entire concept of physics. Several scientific notation. Scientific notation means scientific law, theory, model, scientific method. What is scientific law? Law is a general statement of physical happening in nature that is not created by human being. That is happening in the nature, and if that happening is expressed mathematically, that is scientific law. For example, Newton's law of gravitation is expressed as F equal to G m1 m2 by R square. This you have learnt in class 9, where G is the universal constant. Now the theory. The speculation on the basis of determined law is known as theory. Theory is given by man. It is not given by nature, so it may be wrong. But the law is made by nature. So we human being can't make a law. We only can give that law, express that law. And law is always right because nature is always right. Model a visual picture of phenomenon under study. That is model. Scientific method, combination of logical reasoning, controlled experimentation, observation, calculation. These are now the scope and excitement of physics. First, see the domain of physics. Physics study this physical world in different category. First is macroscopic, that is in the classical physics. Means in bigger sense. Mesoscopic, intermediate between macro and micro. And microscopic form, that is quantum physics. Any observation, however exciting it may appear to be, finds an explanation on the basis of a physical law. All that we observe in nature can be explained and understood in terms of few physical laws. Example, measurement of size of nucleus. See, the size of nucleus is about 10 to the power minus 15 meter. And the size of universe is 10 to the power 25 meter. We must not think that everything can be proved with physics and mathematics. All physics and mathematics is based on assumption, hypothesis, or axioms or postulates. For example, Einstein's special theory of relativity, that is one of the famous theory in physics, that is E equal to mc square, is based on two postulates. First, the constancy of speed of electromagnetic radiation. Means one of the electromagnetic radiation is light, and all electromagnetic waves travel with the speed of light. So, postulate is considered that the speed of light, speed of electromagnetic radiation is constant. And number two, the validity of physical law in all inertial frame of reference. About frame of reference, we will learn in second chapter. Physics is the most basic of all sciences, and it has played a vital role in the development of all other sciences. Now, the role of physics in technology and society. First, physics in relation to technology. The major advancements made in technology can be safely attributed to the applications of physical phenomena. A few advancements made in technology on the basis of physics are appended here. First, the discovery of electromagnetic induction by Faraday has formed the basis of the technology. The study of lever system has helped to design a large number of very useful machines. The study of satellite has made it possible to forecast weather very accurately. Discovery of X-ray have great importance in medical industries and research. Discovery of vacuum tube has led to wireless communication and to design of radio and television. The discovery of nuclear fission has proved to be a tremendous source of energy. Now, physics, technology, and society. Means, what is the role of physics in society? Children, the fate of society is intimately linked to physics. The advancement in the field of communication enable us to quickly exchange of messages between far off places. Microelectronics, laser, computer, superconductivity, and nuclear energy brought a change in thinking and living style. Some of the great physicists and their works, here see, though many more that we can go through our textbook, here some of them taken. Archimedes belonged to Greece, given the principle of buoyancy and principle of lever. Galileo Galilei, given law of inertia. J.J. Thomson discovered electron. Eschen Bosch belonged to our country, discovered quantum statics. Higgs boson particles. J.C. Bose discovered ultra-short radio waves. Albert Einstein, famous due to discovery of theory of relativity. C.H. Towns, laser. This is the very important fundamental forces in nature, how nature works. There are four fundamental forces in nature: gravitational force, weak force, that is also called van der Waals force, you will learn in chemistry, electromagnetic force, and nuclear or a strong force. Now, gravitational force, well known to all of us, F equal to G m1 m2 by r square, where G equal to 6.66 into 10 to the power minus 11 Newton meter square kg minus 2 is called universal constant of gravitation. Properties of gravitational force: it obeys inverse square law, that is, F is proportional to 1 by r square. It is attractive in nature. It is long range force. The graviton is the filled particle of gravitational force. Weakest force in nature, this is the gravitational force. It is a central force and conservative in nature. What is conservative force? We will learn later on. Second is the weak force. Interaction between leptons, between a lepton and meson, and between a lepton and baryon. For example, beta decay. A neutron inside the nucleus changes into proton by emitting an electron and an uncharged particle called antineutrino. Inside the nucleus, if neutron decay, then that is also called beta minus decay, and if proton decay, then that is called beta plus decay. See the reaction. What is this one? This one is the proton. A neutron is converted into proton. Properties of weak force: it is a short range force. It is a stronger than gravitational force, that is nearly 10 to the power 25 times. The filled particle of weak force is neutrino. What is filled particle? That we can see here. Filled particle. The concept of exchange of particle between two interacting bodies is used to explain how two bodies exert force on each other. Means interaction between the two particles, how we can explain. So, a concept of exchanging particles taken. Lepton, a class of elementary particles which include electrons, muons, neutrinos and their antiparticles. The muon used to represent by symbol mu is an elementary particle similar to the electron with an electric charge of minus 1 e. E is the basic charge whose value is 1.6 into 10 to the power minus 19 coulomb. But it has a spin of 12, but with much greater mass of electron. It is classified as a lepton. Baryons, a class of elementary particles which include nucleons and hyperons. Meson, any member of the family of subatomic particle composed of a quark, antiquark. Mesons are sensitive to the strong force that binds the components of the nucleus by governing the behavior of constituent quarks. Now we are here, the fundamental forces. Third is electromagnetic force. About this we will learn in class 12, that is force between two static charge is governed by Coulomb's law, which is given as F equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, where epsilon naught is called absolute permittivity of free space. An electric charge is in motion, produces magnetic force around it. The electromagnetic force is given by Lorentz force. About this we will learn in class 12. Properties of electromagnetic force, that is, electromagnetic force also obey the inverse square law. It may be attractive and repulsive in nature, while gravitational force is only attractive. It is also a long-range force. The photon is the filled particle and it is 10 to the power 36 times stronger than gravitational force. It is also a central and conservative force. And the fourth is the nuclear force. The force inside nucleus, interaction between baryons and mesons. It exists only inside the nucleus. What are the properties here? It varies inversely with some higher power of distance. Though accurate mathematical equation for the nuclear force is not obtained yet, but physics is trying to find out. It is basically attractive. It is a short range force. The pi meson is the filled particle and it is 10 to the power 38 times stronger than gravitational force, and it is a non-central force. See here how the nuclear force, that is the graph. Here in the table, gravitational force, EB takes its strength as 1, range is infinite, field particle is graviton, operates between all objects in the universe. Weak force 10 to the power 25 times stronger. Its range is very short range. Neutrino is the field particle, act between the elementary particles. Electromagnetic force operates between charged particle. It is the stronger than the weak force. Its range is infinite. Field particle is photon. And the nuclear force, which is the strongest in nature, see the range of weak force and nuclear force is nearly equal, but the field particle for the nuclear force is pi meson. It operates between nucleus. Now the nature of physical law. Nature works on certain laws. First, the law of conservation of linear momentum. The statement, in absence of external force, the linear momentum of a system remains constant. You have studied this law in class 9. It can be obtained from Newton's third law of motion. Now, the principle behind this law is homogeneity of space. What is the homogeneity? See, homo means same, gene, that space possesses the same properties at all points. Example, when bullet is fired from a gun, the recoil of gun can be explained on the basis of law of conservation of linear momentum. Second is law of conservation of energy. Says energy can neither be created nor be destroyed. It may change from one form to another. It follows from work energy theorem. Hope all of you studied this work energy theorem in class 9. If not, then again we will study in class 11. It can be obtained from the principle called homogeneity of flow of time. What is the homogeneity of flow of time? Time flow uniformly. It is true for conservative forces only. Means the conservation of total energy is only followed for the conservative forces. For example, mechanical energy of vibrating simple pendulum. And the fourth is nature of, again, physical laws, conservation of angular momentum. In absence of external torque, the angular momentum of a system remains constant. It can be obtained from Newton's third law of rotatory motion that we will study in class 11 itself. The principle behind this law is isotropy of space. What is the isotropy? Isotropy exhibits the properties in a specific direction. See, the space possesses the same property in all directions. You have seen a ballet dancer increases angular velocity by folding arms and bringing the stretched leg close to each other leg. It is done by the use of law of conservation of angular momentum and the law of conservation of charges. The total charge of a system remains the same. So these are the four physical laws. In addition to these laws, there are several conservation laws that we will learn in higher classes, such as law of conservation of spin, law of conservation of lepton number, law of conservation of Brion number, law of conservation of parity. Until 1956, it was assumed that when an isolated system of fundamental particles interact, only overall parity remains the same or is conserved. This conservation of parity implies that for fundamental physical interaction, it is impossible to distinguish right from left and clockwise from counterclockwise. That we have seen. About the filled particles. Now these are the questions. Try to do. What are the basic difference between science and technology? Name a few Indian physicists who have made significant contributions in the field of physics. State the law of conservation of linear momentum and energy. Who discovered electron? Einstein, J.J. Thomson, Maxwell, Newton. What is the role of physics in your daily life? See around you where you find that physics is involved. Now again, there are some test questions. Click the link here given. You will find a set of questions. Try to that one. So all these in this chapter. Next we will learn units and measurement. Thank you.